Hey everybody, this is Larry. This is me with Q3 of the weekly contest 259, Detect Squares. So despite its name, I'm not gonna lie, I misread this as Detect Rectangles for some reason. I think I just looked at a picture very quickly and I missed it. So I actually end up taking about 20 minutes almost to solve this problem, but maybe 15 minutes of those were kind of used because I was trying to figure out how to detect rectangles and optimizing it so it's fast enough. And I kind of almost kind of did it my way because I gave up a little bit. But detect squares is much easier. The way that I think about it is just you know the first thing is that n is 5,000 or n is up to 5,000 in n. So that means that if you loop every time, it's going to be n square ish over 2, if you will. So that's going to be pretty tight, but it should be still okay. I mean, and you can do more tighter bounds to that so, because it's not that's a absolute lazy upper bound, if you will. But yeah, but the idea is that you keep track of you in a brute force kind of way. You want to keep you want to do a traversal, a for loop on everything that shares because either an x or y, it doesn't really matter because you get the other ones anyway. But given 2 points, right? Well, one is that you want another point that's on the same axis of line, right? Either x or the y, it depends on how you want to do it. Doesn't really matter. But yeah, now that you have 2 points that are on the same, let's say, horizontal line, then now that uniquely determines two squares, right? That means that you can have a square that goes up and a square that goes down. And from that, if you have an O of 1 lookup, then everything is straightforward. That's basically the idea that I have. So then the question is, what is it, how do you get a point on the line quicker, right? So the way that I did it is just by keeping track of everything on every x, right? So and I even did a little bit more, but yeah, but basically on the add, this is just setting up. On the add function, I keep track of the point because it's important to keep track of the point. And then here, I don't actually use both of these because, like I said, initially I was thinking about more rectangle stuff, so that's why I have extra stuff. But so you can actually remove this, I think. If not, that'd be funny. But yeah, but then now when I actually do the counting, I do okay. I look at every possible y. That's what py stands for me. On the same x. So that means that for every y. I think I did this the other way actually then. But yeah, for everything that shares the same x on the horizontal line, we look at every vertical slice, right? And here we get the length is equal to y minus py. That's just the length of the differences of where you're going from x. That's the difference between where you are and where it is. So then you get the length. The length is important because then now you're able to do up and down on the square. I also spent some time debugging because of this. If L is 0, that means that you have a 0 area square, and that's no good. So you have to just skip it. Otherwise, then there are two possible x's for the other point, and that is either it is like I said, it's either up or down. So then we check both, and here this one I think now becomes more obvious, which is that we know that xy doesn't have to exist even, but we check whether all these 3 points are inside the points, and that's just basically the 3 other points of the square. And then here we multiply. This is just the number of ways to do them, handling duplicates because yeah, I mean, I think this is obvious because you have X way to do, A way to do 1 point, B way to do another point, and C way to do another point. Then it's just A times B times C. I'm not going to go over that much. Hope that makes sense. And yeah, and after that, that's pretty much it. The complexity of this is, I mean, this is O of 1. This is O of 1 for add. So the hard part is going to be count. And this is just going to be O of n. So where n is the number of roughly speaking, number of points, though in actuality, it depends on the composition of the inputs. So yeah, because it depends on how many things are on the same x or something like that. But it do generates to n square or of n, sorry. But given m cores and each one takes O of n, it'll be n times m complexity. Anyway, that's all I have for this one. Let me know what you think, and I will see you later. You can watch me solve it live next. Keep in mind that I spent a lot of time debugging trying to figure out why rectangles don't work until I really read the problem again. So yeah. Anyway, see ya. Okay, it was a little bit slower than whatever, but it is okay. Okay, you can assume exclamation. Duplicates are allowed. Okay, given equivalent count the number of ways to choose 3 points such as 3 points and a query point form an axis line. Okay. This is an interesting one. Did we also add on the count? Let's see. What is n? 5,000 n squared maybe a little bit too slow. 25 now. Let's see. I mean, I'm thinking about just keeping track of x, y, but is that fast enough? For x, for y, I don't know if this is going to be fast enough, but I think that's the problem with these things is that sometimes you think it's going to be fast enough and whatever anyway. Is it? I guess technically it will not be. Trying to think about how to process this in a good way. Let's just try to do it that way. Yes. Okay. That is set, and then also, maybe that's good enough. I don't know. Let's see. I think it is enough. I don't know if this is going to be fast enough, and I'm going to disagree on it, but see what I want to do? No, that's not quite what I wanted to do. I want something like a lookup in a good way. I think this is closer to what I actually wanted. I got confused. Okay, and then now I can do something like set down the data too. Okay. For possible y and possible x inside that. What about duplicates? I forget how to do duplicates. Okay, so duplicates. you have to count multiple times. Okay. That's actually a little bit more annoying. Not really, actually. But I do worry that this is going to be too slow, but let's see. X11. One O and 2. Okay, that looks good. It's just whether this is fast enough. And maybe I would spend some time generating a case, but I am too lazy. So let's try and see. Can I make it faster? Guess that's what I have to do if this is TLU. Oh, wrong answer. Actually, did not expect that. Okay. This is a mess to debug though. I mean, you barely even see the test case. It's actually surprising. How can this be wrong? So I'm over counting. That doesn't seem like it would happen. Okay. Let's see. That blows though. I was actually expecting the timeout, but not this. This is such an annoying bump, but they need to do it better. They need to figure out how to make it easier to debug in general. But yeah, okay, let's actually add to it. Well, it should be the fourth count. So let's see. So this is given 2, but did I mess up? Well, there are 2 different things, but then maybe there's a duplicate somewhere, but I don't even know. If I'm printing everything, which is kind of sad. So this is 2. Why is there 2? 80, there's 2 8 zeros. Did I misunderstood the problem? With 2 of these. That seems access aligned, so that's okay. Oh, no. Am I looking at the right? Yeah, I'm looking at the right one. I'm returning 3, but the expected answer is 2. There's 2 8 zeros. Yeah, the 2 8 zeros. So am I misunderstanding it? Oh, edges are all the same length. Wait, that doesn't change. I actually missed the square part. I actually did this as rectangle, so this is actually pretty bad. I had to change a lot of things. So this was going to be wrong anyway, but oh, this is 2 because this is not a square, not because of this. So this is right, but this is not right because it's not a square. Okay, that makes sense. That makes it easier, but but I have to do some maths. I mean, I don't know if this is going to be too slow now because mm, uh, because now I have to. I don't know if this is like I have to rethink. I don't know if I can just fix this versus you know X. I just didn't read this one correctly. There might be a cleaner way to do this now, but yeah, oh my god. Is this good enough? I don't even know. Okay, well, maybe without the print statement now. I guess I should have looked at least that case. Ah, of course, internet. Why not be slow? Okay, so this is just wrong. Hmm. Wait, why is this wrong? That's okay though. It didn't even come up. Okay. I have to step back for a second. I thought about the wrong problem. So I have to think a little bit about resetting my mind and thinking about how to do it. I think it's still the right-ish idea. But I think now it's a lot easier because now I can do something like this. So possible y, right? So L is equal to, okay, so if you have x, I have to reset my mind. Yeah, xy, and then now you look at a possible y in here. Okay, so then that means the, okay, I see why I got it wrong. It's the y delta that I care about. Okay. And then now the other points are if, I didn't want to, I guess I didn't want to erase this part. So length is equal to, so then the other points are, oh, it's a little bit mess because now you have left and right, so okay. So then you have for px is in, let's see, x minus L and x plus L. So then now we can do something like this. If and let's see. So the other point is, so x y is in, xpy is in, yeah. That means that p pxy needs to be in. Let's see. This is a mess because I'm having trouble resetting from my previous thing. Okay, that's not great, but let's see. If this is 2, so why is it giving me the wrong answer at the very end? So why is this giving me 1? Oh no, I'm looking at the wrong one all along. This is 2. Okay. Okay, so I'm looking at the wrong thing for debugging anyway, but okay. Is this good? It's so hard to tell. I'm using an external string comparison thing. I guess I could just do it. Okay, I'm just going. Yeah. Oh, what the? I cannot even copy this in an easy way. Oh, jeez. Oh, okay. So I ran a diff on it, and it seems like there is still something wrong. Well, a lot of things wrong, actually. So that's good in that at least I didn't do the wrong submission for it. But now I'm trying to figure out why. Did I do the length one? This is hard. I don't know what I'm going to do. To debug, I mean. I missed the squares part, and that really messed me up in how I want to think about it. I think this is mostly right, though. But I don't know. Well, probably not good enough. But just in case, I guess. Might as well. That was much easier than the way I did it before. Oh, still way wrong. I'll find the first case where this is wrong, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 5 is expected as a... So this number should be a 5. How the hell? How would I do this? 1, 9. Okay, so there's this thing. Okay, so I definitely counted this. So I think it has to be, so it counts itself. Does length have to be 0? Is that the only thing that I'm doing wrong? That's an easier fix if that's the case. I guess so. Why would, yeah, okay. This doesn't really make sense anyway. And also because it is a square, the complexity is much easier. Okay, so now this is good, or at least for this particular thing. Because then now this is just linear instead of n squared, which I was worried about. Okay, there we go. Misread. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem and the explanation. Yeah, stay good, stay healthy, to good mental health. I'll see you in the next problem. Bye-bye.